Oops. It's the opposite of what I want. Okay, camera. All right, here we go. We've got our lesson number 29, direct variation versus partial variation. Move the mouse off there, okay. So today we're gonna learn whether a linear relationship is considered direct or partial. So those are our two new words for today. And once you figure out which is which, it's pretty straightforward. A direct variation or a direct linear relationship has an initial value of 0. So B would equal 0 if you've got a direct variation. Variation just means that that's how the X and Y variables are related, okay? And you have a partial variation if it's a linear relationship that has an initial value other than 0. So any number other than 0. Okay, so B is not 0, it's something else. Okay. So that's a pretty straightforward concept. A line, if the initial value is 0, it's considered direct. A line, if the initial value is not 0, it's considered partial. That's our big idea for today. So we're going to do some examples. First one, consider these two options. So Gym A has a membership fee of $100 plus $2.50 for each visit. So again, when you're reading this based on yesterday, I would want you to see membership fee of $100 and think to yourself, B is 100. And then I'd want you to see the word per, $250 per visit, and think M equals $250 per visit. B is actually $100. Okay, so I want you to be thinking that as you read it. And for Gym B, it's $5 per visit. So that gives you the M. Okay, $5 per visit. But you don't see a B here. If you don't see any kind of B, then probably B is 0. That's going to be our prediction. So let's see what happens. Make an equation to relate the total cost C in dollars to the number of visits N for Gym A and for Gym B. So here we've predicted in Gym A that we've got a B value of 100 and an M value of $2.50. So we're going to start off with our general formula, y equals mx plus b, because all linear relationships fit that. But they want us to use cost instead of y. And remember, here's our little graph here, and we know that cost always goes on the y-axis, the vertical axis. And they want us to use n instead of x. So when you're replacing them, you're going to replace y with c. M is our rate number, so 2.50 is our rate of change. Instead of x, we've got n, and then plus our initial value, which is 100. For Gym B, we still want to start off with the same general formula. We're still talking about cost and number of visits, so we're still going to change y to c. But this time our rate of change, it's $5 per visit, so m is 5. N, and then there's no initial value. So you could write plus 0, but you don't need to, okay? And what I want you to notice is the difference in the formulas. So here we see our initial value is 0 because we don't have a plus b part. So basically, if we have a direct relationship, the equation just looks like y equals mx. The plus b part is missing. Whereas if we have a partial relationship, you can see the b value. Here, we're seeing that the B value is 0. Okay. So in the words, here we predicted the B was 100 and the M was 250. Here we just had an M. So, and the B was 0. So we should have been able to say right away here, direct, partial. B is 0, B is not 0, B is 100. Okay, then looking at the equations, the B value is 100, partial. B value is 0, direct. Now we're going to look at a table and see what that looks like. So for Gym A, if we go 0 times, it still costs us the $100 membership fee. If we go 5 times, we might want to use our equation to figure it out. So remember that what we would do is we would replace n with 5. Into our equation, or some of you just would use common sense. You do 250 times 5 plus 100, which is what I'm going to do here. Uh-oh, was that? No, that is on. Okay. So 2.50 times 5 plus 100 is 112.5. And then to put 10 in instead. So 2.5 times 10 plus 100 is $125 if you go 10 times. If you go 15 times, it's going to be 250 times 15 plus 100, or 137.50. And if you go 20 times, it's going to cost you $150. So that's for Gym A. For Gym B, our formula, I could have written our formula for Gym A right here. Probably smart. For Gym B, our formula is C equals 5 times the number of visits. So if we go 0 times, 5 times 0 is 0. If we go 5 times, it would be 5 times 5 is 25. So this one's much easier to put in our calculator. If we go 10 times, it's 5 times 10, which is 50. It's also easier to see the pattern. If we go 15 times, it's 5 times 15, which is 75. And if we go 20 times, we'd predict 100 because we can see the pattern. And 5 times 20 is 100. So in a table of values, if the number besides 0 is 0, this is our initial value here. And if our initial value is 0, we can see from the table that we've got a direct relationship. Whereas if the initial value, again, the number besides 0 is not 0 or 100 in this case, then we know we have a partial relationship. So there's all these different ways in the equation we can see the initial value is 100, so we know it's partial. In this equation, we can see the initial value B is 0, so we know it's direct. In the table, we can see the initial value 0, meaning it's direct. In this table, we can see the initial value is 100, meaning it's partial. Okay, so far we've been able to see it in the equation and in the table. And now we're going to put it onto a graph. So I'm going to leave the table up so when we're plotting our graph, we can still see the table. So because C says graph both relationships on the same set of axes. So I just want us to be able to see the tables here. I just got to fold this over a bit. Because some of you might have your graph on the back if your printer saves paper. So you can at least see them here. There we go. Okay, so we want to plot these on a graph, both of them on the same set of axes, okay? That's what our job is. So we know that our horizontal axis is our n axis, and they've already got numbers on it for us. But n stands for number of visits, so let's just write number of visits at the bottom here. And same with our vertical axis. They've also already put numbers on, which is nice. So we don't have to figure out the scale. They've done a scale for us. But we do want to say what it stands for. And it stands for, second column always goes on the vertical axis, so it's cost. And it says it's in dollars. So we're going to look at Gym A first. So remember, the first row represents a point, and that point is 0 and 100. 0, so we don't go left or right, and then up to 100. And then our next point is 5 and 112.5. So that's going to be harder for us to put on. So I'm going to leave that for now. I'm going to leave that one. I'm going to show you a little trick here. 10 and 125 is easier to plot because I know 10 is right on one of my lines here. So here's 10. And then I want to go up to 120. I know this is 130 because my vertical scale goes by tens. So here's 120, here's 130, so 125 is right in the middle there. And then 15 and 137.5 is another tricky one, so we're going to put it on after. But 20 and 150, that row is easy to plot again. So 20 and 150, here's 140, here's 150. So if you can get 3 points that you're sure of, and they all line up in a line, you can draw your line in. So this is kind of a little important trick to know, especially when you're plotting lots of points and some of them are tricky to know where they go. So now I can go back and find where 5 is. 5 is halfway between 4 and 6, so it's in the halfway here. Where it meets the line is going to be that point 5 and 112.5. So this point should look like it's at 112.5, and we know this is 110, just above, so it looks pretty good. And then we can put on the 15. So here's 14. So 15 is going to be halfway up here till I hit the line. Then I'm going to put a point on. And if you read across, that should be 137.5, which also makes sense. So there's a little trick on if you've got some easy points to plot those ones first. If they lie in a line, you've plotted them correctly, and then you can go back and use those harder ones and check and make sure they make sense. And whenever you put two lines on the same graph, you want to label them. So I'm going to label this first one because it represents Gym A. I'm going to label it Gym A, so we know that that line is for Gym A. Okay, so that was, even though they put the points on us, this one was a bit tricky because some of the points were tricky, and that was the way we got around it. So now we're going to look at plotting the points for Gym B. So the first row represents the point 0, 0, which is right down here in the origin, or we call it, or the bottom left corner is 0, 0. And then 5, which is halfway between 4 and 6, and 25. It's going to be right in the middle of that square. Again, if you didn't feel comfortable plotting that one, you could leave it and go to some of the easier ones, like 10 and 50 is easy. 40, 50 right there. And we could leave 15 and 75 and go to 20 and 100 right here. And then draw in our line with a ruler. And then label it Gym B. And then we can go back and fill that 15. So 15 is here. 75 should be here. And it does look like here's 60, here's 70. So 75 would be in the middle. And it makes sense with where our point landed. Okay, so you've done your graphs. That was C, graphing both relationships on the same axis. Part D now says which relationship is a partial variation. Justify your reasoning. So I just wanted to point out graphically, if you're just looking at a graph to tell whether something's direct or partial, on a graph, you can see the initial value. So here we see for Gym B, the initial value is 0 because it goes right through that point 0, 0. And for this Gym A, the B value is 100 because it starts at 100, okay? So again, having a initial value of 0 means we have a direct relationship, whereas having an initial value other than 0 means it's a partial relationship. So which relationship is a partial variation? And justify your reasoning. So we just need to say then, Gym A is a partial variation. And justify means you have to add the word because. And then you just have to say what the initial value is. The initial value is, sometimes you can write B equals, or you can just write what it is, B equals 100. Or you could just write the initial value is $100. So again, partial variation, the B value is any number other than 0. And then we're going to do the same thing for E. Which relationship is a direct variation, and justify your reasoning? So Gym B is a direct variation because the initial value is 0. Okay, so that was the first question. And in that first question, we saw how to tell from an equation if it was partial or direct, how to tell from a table whether it was partial or direct, and how to tell from a graph whether it was partial or direct. And then just what we had to write to justify our answer. So that's the main idea. We're going to do another example. Oops. All right, so example 2, consider these two options for an amusement park. Option A is an all-inclusive pass for $50. So that means you just have to pay $50 and then you don't have to pay anything more for any rides. And then option B is an entry fee of $10 plus $2.50 per ride. Make an equation to relate the total cost C in dollars to the number of rides N for option A and option B. Okay, so this one's a good question. So for A, remember we're always going to start off with y equals mx plus b and change it over. So let's think this through here. So we're relating cost. Cost is going to be our y variable. And N is going to be our X, number of rides. So we're going to replace Y with C. But for an all-inclusive pass of 50, that means at 0 rides, if you go on no rides, you still have to pay $50. And if you go on 20 rides, you're still going to have to pay $50. So you're going to have this horizontal line. which means that your rate of change, M here, is 0 actually. Okay, because there's no cost per ride. No cost per ride. So that means you would substitute in 0 for your rate of change times N plus my initial value is 50. But hopefully, you know, if you multiply 0 by any number, you get 0. So this term 0 times N is really 0. It doesn't even need to be there. So your equation for A turns out to be just C is 50. C is 50. But for option B, we'll start off with y equals mx plus b. Our y variable is c. Our rate of change, m, is 250 per ride. So 2.50 is our rate of change. X is n in this case, plus our entry fee is $10. So for this one, we start at $10, but then the more rides we go on, the more we have to pay. Okay, so we do have a rate of change. It's not just flat 0. So there's our thinking, and there's our equation. This is our equation for A, and this is our equation for B. So complete a table of values for each option. So option A is where the cost is always $50. So if you go on 0 rides, it costs you $50. If you go on 5 rides, it costs you $50. If you go on 10 rides, it costs you $50. It always costs you $50. That's what the all-inclusive pass means. Okay. And right away, you can see that right beside 0, we have the number 50. So this is our initial value. So right away, we can see from our table that B is 50. So that would mean we know this one's a partial. And for option B, which is this option here, if we go on 0 rides, we still have an entry fee of $10. So this one's also partial. 0 rides still cost $10, so B is 10, which means we've got partial again. But it's not going to stay 10 all the way down because it costs $2.50 per ride. So if we go on 5 rides, we have to work that out. So it's going to be 2.50 times 5 plus 10, $22.50. For 10 rides, 2.50 times 10 plus 10 is $35. For 15 rides, 2.50 times 15 plus 10, $47.50. And then 2.50 times 20 plus 10, $60. So we've got our tables. We've already figured out both of our relationships are partial. Now we have to complete a graph for each option. So I can fit my tables in the screen there. So option A, it's always 50. Sorry, let's label our axes first. I'm neat about this. So N stands for number of rides, even though they put the numbers on for us again, we still have to label what the axis represents. And C represents the cost in dollars. So if we're completing a graph for option A, if I go on 0 rides, I have to pay $50. 5 rides, so this is 2, 4, 6. So 5 is here, $50. 10 rides, which would be here, $50, 15 rides. So this is 14, 15 would be here. And then 20 rides. So your line's going to look completely horizontal. And then because we're putting two lines on the same grid, we're going to label this one A because it's option A. And then we want to plot our points for option B. So the first row represents the point 0 and 10. So 0 and 10 right here. The second one looks like it could be tricky to plot, so I'm going to go straight to 10 and 35. 10, 35 would be here because we count by fives on this vertical scale. And then same thing, the next row looks like it would be tricky, so I'm going to go to 20 and 60, which is right here. So I've got 3 points. If they all line up in a line, then I've plotted them correctly. And I can use my ruler going right through the centers of the points. And then that's my option B. And then I can go back and fill in the ones that were tricky, like the 5 and 2250. So 5 is right between 4 and 6. And where it hits the line should look like it's 2250. So if this is 20 and this is 25, 2250 should be halfway in that square, so it makes sense. And then 15 would be halfway between 14 and 16, and 4750. And if I read across, here's 45, so that makes sense as well. So we've done C, we've completed a graph for each option. Which option represents a direct variation? Circle 1, option A, option B, neither. That wasn't a good. They're both partial, right? Oh no, sorry, neither. It's direct. Okay, that's my bad. I was thinking wrong here. Okay, so which option represents a direct variation? Circle 1, option A, option B, neither. So we circle neither because we know they're both partial. And then we have to justify our reasoning. So our reasoning for why they're not direct, neither option is direct because option A has an initial value of $50 and option B has an initial value of $10. Okay, so remember direct means that they would have, one of them would have, or both would have had to have an option initial value of 0, but neither one did. You can see it on the graph. None of them go through that 0, 0. You can see it in the table. Neither of the two initial values are 0. 0, 0 isn't in one of your charts. And in the equations, you can tell what the B value is, and the B value isn't 0 in either of the equations if you go up to part A. Okay, so we're going to go to the very last page now. We'll come back and finish the other questions at 10:30, but I want to go to that chart and fill in the first two sections of this chart here. So this chart says, how do you tell if a linear relationship is direct or partial from the graph, the table, the equation, and the word description? So we're going to fill the first two columns in, and then we'll do the other two columns after we've done the last two examples.
Did Miss Northwood leave?
Yeah, it looks like her internet went out.
Well, looks like the school day is over now.
How long was I out for?
Quite a while.
Oh no. Oh no. All right. Sorry guys. I will. Did we get the first example done?
No, you said we were
No.
going to start the last page and then you went. So.
Wait a sec. So what did you guys hear?
Nothing.
No, okay. We were on the last part of the chart where it was like the graph and the table is the table of values, and then that's when you cut out.
So you saw the first two examples.
Yes.
Okay, we're good then. I'll reprint the chart and we'll do the chart at the next meeting, okay? Is that okay?
Wait, we took up the first two columns? I don't remember doing that.
So some of you saw the first two questions and some of you didn't?
I didn't.
Do you mean questions on the lesson or columns on the chart?
The questions on the lesson.
Questions on the lesson is fine.
So we did question 1 and question 2.
Yeah, that's fine. I thought you meant that some people heard the first two columns, and I was like, I did not.
Oh no, okay. So the chart we didn't do. So I'm gonna go back over the chart in the next meeting. You don't really need the chart for the questions that we're gonna do. Okay. Actually, you know what? I'll just put the document camera on the chart, and that's what we'll do. You guys can copy the chart out now, and I'll go over it again, and then we'll pair off. So I'm gonna present now again, and hopefully not lose internet this time. Yeah, my internet cut out and I had no idea. I was just so into my lesson. You should have come up right away when I did that.
I was sat on the floor, but you said it was okay.
No, I didn't know. And they can't tell me because there's no.
I went to the 5.
Yeah, I did too once I realized. Okay, can you guys see this now? Hello?
Yeah, we can.
Yeah.
Okay, good. Okay. All right, so I'll just go over this piece by piece again. Okay, so for a direct relationship, you need to have a graph that goes through the point 0, 0. Okay, so the line must go through the point 0, 0. The initial value must look like it's at 0. So let's just focus on this first little part in our chart here. For a direct relationship, for a graph, you have to have a line that goes through the point 0, 0. So make sure you've made a little picture and said that the line has to go through 0, 0 to be a direct relationship and to be able to tell that from a graph. Once you know that, for the partial relationship one, there's so many different ways that you could not have an initial value of 0. I wanted to remind you of a couple of them. So I did one that has a negative slope where you can see the initial value starts way above 0 and goes downward. So that's an example of a partial relationship. I did like below it, I did our regular one where you can see your initial value doesn't start at 0, 0 and it goes upward. Those are kind of like the ones we just did. Then I did one where your initial value could be in the negatives, like if the plant starts growing underground, or the profit question where you had to spend money before you could make money, you can have a negative initial value. One I forgot to put in, I can just add right now, is like the amusement park one, where you just pay a constant, you pay one fee. You can have a flat one where your initial value is not 0. So there's so many different graphs where your initial value is not 0. But the important thing to know for a partial relationship in a graph is it's not going to start at 0. Okay? As long as your graph doesn't start at 0 and it's a straight line, it's a partial relationship. So just if you're looking at the graphs, direct has to go through 0, 0. Partial can start anywhere else except 0. Your line. So then I was into doing tables of values. And the first example was a table of values where you were given your X and Y, you were given 0, 0, 2, 5, and 4, 10. And you could see right from the chart that the initial value is 0. So whatever number's in your Y column beside it, when X is 0, if Y is 0, then you know the initial value is 0. The second chart I did, I didn't have 0, 0 in it initially. So I started my chart with like 5, 25, 10, 50, and 15, 75. So that 0 wasn't in my chart at all. That's kind of like the harder type where you have to figure out what the initial value is in the chart. And you do that using differences. So this one had a pretty easy pattern to follow. The X column was going up by 5s and the Y column was going up by 25s. So if you had to work backwards to get to 0 on the X side, you would have gone back by 5 to get to 0. And then if you had to work backwards on the Y side, you would have gone back 25, and 25 minus 25 gave me 0. So even working backwards, I got an initial value of 0. So in your table of values, if the initial value or the number beside 0 in the second column is also 0, you know you've got direct. Okay. And then I did the same thing here in the partial column. I started where you were given a chart that had 0 right in it. And you can see that the number beside 0 was 10, which let you know the initial value was 10. So it's partial. So if 0's right in your table, then it's easy. You just look at the number beside 0 in your table. That's your initial value. If it's not 0, like a number like 10, you know we've got partial. If it is 0, you know you've got direct. And then the harder version is when, so for this one, I didn't put 0 in the table. My table started with just 2, 12, 4, 18, and 6, 24. I didn't put 0 in the table. That's the harder version of a table where you have to work backwards to see what the initial value is. And then I made a pretty easy pattern again, where this side was going up by 2s and the right side was going up by 6s. So to work backwards on this side, I had to go back by 2 to get to 0. And on the right side, I would have had to go back by 6. 12 minus 6 gave me 6. So even though 0 wasn't in my table, I could work backwards to figure out what would be beside 0 in the table. It was 6, which is not 0. So I know this one is partial. So that's how far we got in the chart, and that's where I wanted to stop. And then when you work with your partner, you're going to be working on questions 1, 2, and 4 from the practice. 1, 2, and 4. Until we meet again at 10:30. So I'm going to get out of this now. Okay. Could you hear it that time?
Yeah, we did.
Yeah, okay, good. All right, so I'm just gonna stop recording.